This video is continuation of part 2A of the Cloudhub networking series. In the previous video, we saw the basics of VPN. Now it's time to leverage those basics and understand how a VPN works. So I'll be covering these three processes which are used in creation of VPN. Followed by this, there would be a demo. Now remember, the demo will not be a full-fledged demo. I'll not be able to show how actually the VPN is getting created. I won't be able to show the exact configuration that has to be done at the customer gateway because that requires a router. What I'll be able to do is I'll be showing how the Anypoint platform looks like, what are the options available for configuration, and will download a configuration file which shows what all parameters are to be applied on the router, which is a customer gateway router. That should give you a very good idea of what all needs to be done while setting up a VPN and as well as how the VPN works. So let's get started. Before we begin, a few basics that you should keep in mind. The two routers, one to the left, virtual private gateway on Cloudhub, which is in turn AWS, and the customer gateway at the right are called as peers. A peer can either be an initiator or responder. Initiator, as the name suggests, initiates a connection. Responder then starts working with the initiator to create the connection. In Cloudhub, usually the initiator is the customer gateway and Anypoint VPN acts as the responder. However, things have changed recently with improvements at the AWS end. So now Anypoint VPN can also behave as an initiator, but it has some restrictions. I've placed the link to the support article which discusses all the restrictions in detail in the description box. Please consider reading it. Alright, back to the topic now. So interesting traffic is the first step towards creating VPN connection using IPSec tunnel. Now interesting traffic refers to what type of traffic should be eligible to be sent through the tunnel. Not every traffic needs to be sent via the tunnel. Typically, there are three options that are available on any router. First is to encrypt using IPSec VPN. Now here in the router, you specify the source and destination network. So any IP packet moving to and fro between the source and destination will be encrypted. For example, over here, any traffic originating from the network 10.0.0 with a subnet mask of 24 directed towards 172.168.0.0/24 has to be encrypted. So all the IP packets moving between will be encrypted. This is one option. Other option is you specify which traffic has to be sent into clear text. Now not all traffic needs to be encrypted. For example, there is a network connected to this router which is 10.0.0.24 and it wants to access the internet. Now routing this network to the internet via VPN will be expensive and such traffic can be directly routed to the target servers without VPN. So to do so, we can configure this option. And the last one is to discard the traffic. Now you can specify the state of traffic coming from the source. For example, here the source is 10.0.0.024 network and any traffic coming from this network to this network has to be encrypted. In case if the net data or the IP packets coming to this router from this source are not encrypted, which means that someone is spoofing in between and sending unencrypted data. So in such cases, you have to discard the traffic. So such rules can be used to determine the interesting traffic. So this is how you can use discard traffic mechanism, and this is configurable on the router, which is the customer gateway mostly. Also, one thing to note in the second point that we saw that the any normal traffic going from this network which had to reach the internet was going through the tunnel and getting encrypted and then going to the internet. So this can directly be routed. So we can use this send in clear text and define the rules. And this also is sometimes called as split tunnel, because despite having a VPN, this is bypassing the VPN traffic and directly going to the internet, because it doesn't have to go through the VPN, right? And ignore this key, because when it directly goes bypassing the VPN, it doesn't need to be encrypted, which means the IP packets need not be encrypted. Remember a point that whenever the traffic is routed via the VPN, the whole IP packet gets encrypted. So, irrespective of the fact that you are using HTTPS, FTPS, SFTP, or any other protocol, it works at a very low level and encrypts the whole IP packet. And after that, the HTTPS or SFTP or FTPS protocol come into picture. So this is what makes a VPN quite expensive. It will increase latency while communicating between each other. Also, keep in mind that this interesting traffic, you see a VPN tunnel created, it's just for demonstration purpose. VPN tunnel gets created post the trigger of interesting traffic. We need something to trigger the traffic, and once the traffic is triggered, the other phases come into action. The Internet Key Exchange, also known as IKE, has two phases. In the first phase, a tunnel is created by establishing security association between two peers. Now, before we move ahead, please assume the IKE to be version 1 unless specified. So, the IKE phase 1 involves 3 steps. First is the negotiation, DH key exchange, and authentication. Let's call these two routers as peers. Both the peers will have IPSec policies configured, which contain the following parameters. For example, here hashing is SHA-1, authentication is pre-shared key, DH group is DH1, encryption is AES 128, and lifetime is 1 day. So the lifetime specifies that how long the same shared secret will be used within the tunnel. Once the lifetime duration has elapsed, a new key will be generated. Now, if you are having difficulty in understanding these parameters, I would recommend you to watch the previous video in this series, which covers all of this in detail. Now, the collection of these parameters is also known as security association. Both the routers or peers negotiate a common policy where all the parameters are a perfect match. If no matching policy is found, then a new one needs to be created at either end with exact same configuration of parameters as that of the other peer. Otherwise, this step will fail. So in this case, if you observe, this policy or the security association exactly matches with this. All the values are matching, but this one does not match on the other end, neither with this, neither nor with this, right? And same applies for this, right? So the matching ones from both the ends will be taken for negotiation. So the matching ones are found and the other ones are discarded. But from Cloudhub perspective, it's the Cloudhub peer that dictates the policy. So once you create a VPN on Cloudhub, you get a configuration file with details of the security association, and the same security association should be configured at the customer gateway for this phase to be successful. Assume this to be Cloudhub and this to be customer gateway. So exact same policy has to be created here so that it turns out to be a perfect match, and then the same policy or the security association will be negotiated. Now this security association comes from the IPSec protocol, which is Internet Security Association and Key Management Protocol. So we are done with the first step, which was negotiation. Both the peers have successfully negotiated a security association. Now after this, there will be a DH key exchange using Diffie-Hellman algorithm, which was specified here. So it was DH group 1. So using this, there will be a DH exchange taking place. So once the DH exchange is successful, both the peers will now have a shared secret, and using this shared secret, they can create multiple symmetric keys which can be used later on to encrypt the payloads or the messages. Now the final step will be authentication. Now we saw that among the security parameters, the authentication was set to PSK, which is pre-shared key. Okay, there are two modes, PSK, and one can use RSA, which is using certificates. So using the PSK, if the whole authentication is successful, then a tunnel gets created successfully. Now again, if you are having difficulty in understanding the authentication phase, which I haven't explained here, but this has been explained in detail in the previous video of this series, so consider watching that. So this is the IKE Phase 1 tunnel. The negotiations in the IKE Phase 1 can be done in two modes, main and aggressive, based on the configurations performed on the router. The main phase uses 6 messages to perform IKE Phase 1. It's more secure as compared to aggressive mode, as the router's identity is encrypted. The aggressive mode, as the name suggests, requires a reduced number of messages, that is 3 messages, to perform IKE Phase 1. It basically squeezes the data being sent into 3 messages instead of 6 messages. Now this certainly comes at a cost. Now the cost is that the router's identity gets exposed as it is sent in plain text. However, it's faster due to less overhead. Again, these two modes for Phase 1 are applicable only for IKE version 1. Also note that IKE Phase 1 is performed using UDP protocol on port 500. So in case if there is any firewall rule blocking connections on this port, it needs to be taken care of. The IKE Phase 2 is also known as IPSec tunnel. The main function of IKE Phase 2 is to protect the user data. There is only one mode used in IKE Phase 2, which is the quick mode, which involves exchange of 3 messages. Again, this is for IKE version 1. Since the IKE Phase 1 tunnel is already created, the negotiations happening for this tunnel will be governed by the IKE Phase 1, that is the ISACAM tunnel. So all the negotiations here are secured here, as encryption, hashing and authentication has already been configured in IKE Phase 1. Now even in IKE Phase 2 there will be negotiation, but the negotiation will be for the security of the user data, as opposed to the negotiation done in Phase 1. So it follows the same procedure. It negotiates the policies. So the parameters, the security parameters are the same, with only one difference, that authentication is removed because that's already taken care of in previous phase, and we have something called as mode. So let's discuss properties one by one. So hashing, as we know it takes care of integrity. So it's SHA-1. There could be multiple policies on router configured, and again based on the best match, the exact match on both the routers, the policy will be selected. So everything same as Phase 1, it's just that the goal of this policy is for user data, and one of the parameters have changed. So IPSec protocol, this is again a new parameter which is added. So there could be two options. One is AH and other one is ESP. We have discussed this in detail in the first video of this series, so I won't be discussing more over here. Again, there is DH. Now Diffie-Hellman group is optional in case if it's perfect forward secrecy. Now you may want to choose or you may ignore it. So if you choose it, the only difference would be in case of the second phase, it will again try to create a shared secret key. So it will create a new shared secret key, and based on that shared secret key, the symmetric keys will be created. So the Diffie-Hellman was already done at group 1. If that's fine with you, you can ignore or skip this, but if you want added security, you can always have a DH with perfect forward secrecy. Now in Cloudhub, the configuration file that you get, in that it's already the DH is enabled for the phase 2 as well, so it's the same thing. So the key exchange will take again place in for phase 2. It's just that it's for someone trying to hack in, it will become difficult, because now we have the Diffie-Hellman done in the phase 1, and there we got different keys, and the phase 2 will again have different keys. Encryption, now there can be various algorithms and you can choose whichever you want. Lifetime, again, now lifetime is quite important, because lifetime is the parameter that decides when the symmetric keys will be refreshed. So here it's 1 day, so after 1 day it will again change the keys. It's important to refresh the symmetric keys in order to maintain security. Mode is tunnel, so you can also have transport, and this has been discussed in the previous video. Consider watching it if it doesn't make sense to you. Alright, so once all this configuration are done, now the routers will negotiate and select the best possible match. So these two policies don't match. This doesn't match with this one, also it doesn't match with this one, so this one gets rejected right away. Okay, and this one matches with this completely. It's completely matching SHA-1, SHA-1, AH, DH5, AES, 1D, and mode is tunnel. So both of them matched, and the tunnel will be created using the shared secret negotiation. So using Diffie-Hellman, a shared secret will be agreed upon, and finally the tunnel will be created. Now if you observe here, the IPSec protocol is selected as AH. So if it is selected as AH, the data going inside the tunnel will not be encrypted, because AH doesn't encrypt. It's for authentication. It allows only authentication and integrity. It doesn't allow confidentiality. So if you want the payload to be encrypted, you use ESP. The encryption, now you might be wondering that all those things were sorted in phase 1 tunnel, right? But those encryption was done for negotiating the policies for phase 1 and for the second phase, right? So again, for data you need to specify the IPSec protocol, and it should be ESP, so that the data is encrypted. So once everything is done, the tunnel gets created. Observe that the phase 2 tunnel is created inside the ISECM tunnel. So this is the tunnel in which the actual traffic will start flowing. So that's about the IKE phase 2 or the IPSec tunnel. So here are the differences between IKE version 1 and IKE version 2. So first is, we have seen in phase 1 there were two modes, main or aggressive. IKE version 2 has only one mode, which is IKE SA init mode. Quick mode was present in phase 2 for IKE version 1. IKE version 2 has IKE auth in phase 2. IKE version 1 uses high bandwidth, This one version 2 uses low bandwidth. Now in IKE version 1 there is no built-in mechanism for keep alive. Okay, so in case of IKE version 1 you might have to implement some application that sends some ping request or something so that the tunnel is alive. If it remains idle for certain amount of time, the tunnel goes down. But IKE version 2 has built-in mechanism for keep alive, so you need not try some workaround for that. IKE version 1 supports pre-shared key and certificates for authentication, whereas IKE version 2 supports both pre-shared key certificates. In addition to it, it supports EAP for authentication. IKE version 1 lacks built-in NAT traversal. IKE version 2 has built-in NAT traversal. Now Anypoint Platform allows both variations of IKE, but in most of the cases you would see that the one which is widely used is IKE version 1, although you can use IKE version 2. IKE version 2 is comparatively new. IKE 1 was launched around in 1998 and IKE version 2 started in 2005. Now that we have understood the basics of VPN, let's try to create a VPN on Anypoint Platform. So to create a VPN, log into your Anypoint Platform account, go to Runtime Manager and click on VPNs, and here you can create a VPN. Click on Create VPN. Once you click on Create VPN, it should open up this page. Now you need to fill up all the details. Let's go by each of the details. So name, it should be unique. Let's give the name as Demo VPN. Alright, then you need to select a VPC with which you want to associate this VPN. So I have selected Demo VPC that we created in the previous video. Remote IP address. Now this is the customer gateway, which is your on-premise gateway. So you need to enter the public IP of your customer gateway, which is the router at your end. Routing is static or BGP. Now BGP stands for Border Gateway Protocol. Now if you select static, you need to provide the CIDR block of the next hop, which is the router or the network which is responsible to route the data. So static, as the name suggests, you will have to hard code it for once, and then based on the routing configuration done on the next hop network, it will route the traffic. But if you want things to be dynamic, you can use BGP. Now if you click on BGP, you will have a few options like remote ASN and local ASN. Now ASN means autonomous system number. Let me explain briefly what is ASN. So internet is network of networks, right? So the ISP or the internet service providers have their own network. Now I as a user am connected to an ISP. So the ISP will have multiple IPs, right? And this IP will basically form a group which is called as network. So every ISP or any organization, right? For example, Google, Facebook, they'll have multiple IPs allocated to it, and they'll have their own network. So ISPs or the internet or any big organizations will have their own networks, and they are quite huge network. So they can have a public autonomous system number. The benefit of the autonomous system number is that it helps in identifying a network uniquely. And even in ASN, similar to IP addresses, there are public and private ISNs. So private ISN value can be anything, but if it is a public ASN, it has to be registered with IANA. So in short, ASN is grouping of a network which basically belongs to any organization, and it helps in routing the traffic. This is quite brief, but internally there are a lot of concepts in it. Now the border gateway protocol. Now border gateway protocol, when you select it, it's a dynamic protocol. So this protocol automatically updates the routing table based on availability of the network. So if a network goes down, it's smart enough to update the routing and pass this information to the other network or the adjacent network. So with the help of this, you need not every time update the routing table, but it's automatically taken care of. So for that border gateway protocol routing to work, you need ASN, so that you know which network to deal with, right? So the local ASN is the Anypoint Platform's ASN, and the remote ASN is your organization or the on-premise. So it's a customer's ASN, right? So by default it's 6500. You can change the value as required. You can give a value. You can consider using private ASN, that's fine. But so it says, right, it's a valid local ASN, so it only wants a private ASN. You can, if you change the value, it also says again it's valid. So ensure that you use only a local, which is a private ASN. You need not use a public ASN. So once you configure the ASN, so remote ASN should be the one which is on your customer gateway, and local ASN will be by default. You select the default values as suggested. So here it's 6500. If you do not want to use BGP, you can use static routing. Alright, and then the tunnel configuration. Now by default, Anypoint Platform creates two tunnel, which can be in active and passive mode. So if tunnel 0 goes down, tunnel 1 might come up. If tunnel 1 goes down, tunnel 0 will come up. So you can specify a pre-shared key of your own and the CIDR block. But if you keep automatic, so the pre-shared key and everything will be suggested or automatically calculated by Anypoint Platform. Once you give all the details, so let me select BGP, give it as 6500. It's not valid. And if I give the remote IP address 117.120.0.0, it works fine, and the button gets enabled. So clicking on this will create a VPN. Once the VPN is created, it will be available in the list here. So remember, it might take some time, and also the tunnel status would take some time to come to the status up. Now this is an active configuration wherein both the tunnels are up and running. Also note that in case if you want to get the VPN ID and the VPC ID, you can get it from the URL itself. So here VPC ID is this part and this is the VPN ID. So you might find it handy when you might want to use a REST API to edit your VPN details. Let's look at some more details of the VPN. Now remember, previously I said that the VPN should get ready once I click on the create VPN button, but that's not the case. The VPN gets created, but for it to be active, you need to configure the details on the customer gateway, and that can be done by getting the configuration, device configuration from get VPN config. We'll come to this later on. First, let's see what all details are available. Now this is already configured VPN, and that's the reason you see it as running. Now created shows the time stamp when it was created. Remote IP address is the one that we configured, so this is the public IP of the customer gateway. VPC is the VPC associated. Remote ASN and local ASN are as is what we configured. Now this is the tunnel configuration. We have two tunnels created for reliability. If one goes down, we always have the second one, and both of them are up, which is an active mode. Now this depends on what have you configured on the customer gateway. Now in this case, both the tunnels were configured on the customer gateway and both are running. You can also choose one to be up and other to be down, depending on how you configure on the customer gateway. Now you see tunnel status, both of them are up. Status message 13 BGP routes, so it was able to get 13 BGP routes, which is both the tunnels have 13 routes accepted. PSK is the pre-shared key, so the same key has been shared at the customer gateway end, and this has been hard coded into the configuration. So with this key, with both the routers at Cloudhub and the customer gateway is able to authenticate each other. Then it has different other details like last status change, local external IP address. So this is the external IP address of the Cloudhub VPN, and this is for the tunnel 2. Local IP address and remote point-to-point, these are link local addresses. So these are used to like configure, assign IPs and all those. So this is not much related. It's related to the internal workings. So this is how the overall VPN looks like. Now let's open up the VPN config and see what all is available in it. To configure the VPN at customer gateway, you need to download the VPN config. So this can be done by clicking the VPN config button. So once you click on it, a pop-up comes up. You need to select the device vendor. If it applies, select one. If it does not, then use the generic one. So the device platform, now since it's generic, select generic. Device software will also be generic. So once you select all of them, click on view config and it will just show all the config. So what I'll do, I'll copy and paste it on a notepad so that we can better understand what is the configuration. So here's the sample configuration that gets downloaded. So I've chosen the platform and vendor as generic so that it's easy for us to understand. Now depending upon the router that you have at your customer gateway, it could be Cisco, Strongswan or any other brand, you may select that option and download the configuration file accordingly. So it might basically have the steps how you configure in that particular router. So the vendor, platform, software, all is generic, and this is an example configuration file. BGP is the routing that we chose, so border gateway protocol. If it was static, it would have been static over here. Now this configuration consists 2 tunnels. Both tunnels must be configured on your VPN endpoint. So 2 tunnels are for reliability. So we saw in the example previously, like a VPN tunnel gets created, but for that you have 2 tunnels, IKE Phase 1 and internally IPSec tunnel. So now a pair of these tunnels will be created. So IKE Phase 1 inside IPSec and another one which will be the same. So 2 tunnels for added reliability. Now it says that these are the minimum requirements, and you can adjust the configuration to make use of other supported values which are listed here. So this says that you can change the value for encryption, hashing and the Diffie-Hellman group, but only those values which are listed at this URL are supported. So it means that it doesn't necessarily mean that you follow the exact same values. You can select the values based on the specification given at this URL. Now let's start with the configuration. So IKE configuration is there. So phase 1 and phase 2 will be done, and you have to configuration IKE. So the IKE version, you may select IKE 1 or V2 based on your requirement. So you can choose to use this right away, or you can choose to change it accordingly. Alright, so the pre-shared key is already configured, so I don't think you'll be able to change this because it's already embedded in the router at Anypoint VPN. So this should be the same that you'll have to use, but you can change the IKE version which you want. Okay, you can change the hashing algorithm. I'm not sure why it's authentication algorithm, but it's hashing. The encryption algorithm, you can choose this or based on your requirement. Lifetime is the time when they refresh the keys, so you can set accordingly or based on the list which is presented at this link. and then the diffie element group, so it takes a group 2. And phase 1 negotiation mode is main. You can also choose aggressive based on your requirement, but mostly it's main. So this is for tunnel 1 and this is for tunnel 2. So say similar configuration, it's just that you just have to change the pre-shared key. So this has to be done on the router end. So always remember, it's the router or the customer gateway which initiates the VPN connection. So you can choose what to dictate, and based on, but the values should be supported by the Anypoint VPN router. So if you choose a diffie element group which is not supported, for example the diffie element group 2, 14 to 18, 22, 23 and 24 are supported at the moment, but if you choose a group which is not supported, in that case the connection won't be established. So you have to configure it accordingly. Now next is the IPSec configuration. So when the first tunnel is created, which is IKE tunnel, so 2 tunnels for IKE will be created, and inside those tunnel there would be IPSec tunnel, right? So you choose the protocol. If you want ESP, AH, based on your requirement, authentication algorithm, so HMAC, so it's hashing, HMAC SHA-196, choose the encryption and the lifetime, and the mode. So we have 2 modes, right? Tunnel and transport. And perfect forward secrecy, if you want you can use, or you can skip this, so it's optional. So now the IPSec dead peer detection. So if a peer is dead and it's not reachable, so it will use this configuration to retry the connection. Now here are a couple of more configuration. So if you select ESP, it will encapsulate the security payload, basically encrypt the payload, right, which leads to a consumption of additional space. So they are suggesting to use this configuration to improve the performance. Now next is the tunnel interface configuration. So finally the IPSec and IKE Phase configuration is done, but now to actually link the router you should know the IP addresses, right? So this is the IP address of a customer router. Remember, this address should be static IP address. If it changes, the whole VPN goes for a toss. So ensure that the other end IP is a static one. And this is the MuleSoft gateway IP, and then customer gateway private IP. So this is the link local space that's being used, and same for MuleSoft. And then you can configure the maximum transmission unit. So maximum transmission unit is the size of frames that can be passed over this connection. Same for tunnel 2. So this is for connectivity options, and then the border gateway protocol. So it's to exchange the prefixes, right? So we discussed previously, like BGP is to determine the routes of how the traffic will be routed, right? So the border gateway protocol ensures dynamic routing, because it will automatically manage and be aware of what routes are available and what routes went down, so the traffic can be sent across easily. So this configuration is related to that. If you choose static, in that case you won't have this configuration, but a single network address which tells you where you want to send the route. But if it is border gateway protocol, then you need to do this configuration, and it will automatically get the routes based on what the other system is publishing, based on the prefix that are being published. So it says that maximum of 95 route table entries is permitted per VPC regardless of the number of VPN connection. So for one VPC you can have 95 irrespective of the number of connections you have. So that's about the whole configuration. So to understand this configuration, you need to have a very good understanding of the topics that we have discussed in the previous video and this video. Unless and until you don't do the groundwork, you won't be able to understand what's being done over here. So that's very important, and that is why I took the whole pain of making videos around the concept of VPN. Without that, it's just a piece of configuration and you just give it to your network engineer and he takes care of. But it's important for us to understand what's really happening and what do this value mean. So now it's just matter of configuring on the other router, and then the connection should be established. So it allows 2 tunnels, okay, and using the 2 tunnels you can send the traffic. So if you configure only 1 tunnel, it could be that only 1 tunnel is up and running and the other tunnel is down. So it all depends upon the configuration that you have done on the customer gateway. And always remember, customer gateway will initiate and Anypoint Platform will act as a responder. However, in the recent time there have been changes, and now even Anypoint VPN can act as an initiator, but that's a new feature. But until now the customer gateway acts as an initiator. So you can specify these values based upon what is available, based upon your requirement, and also based on what is supported by Anypoint VPN. So finally, here's the high level view of what we have seen so far. We first started with the VPC, we understood VPC. Now to connect Anypoint Platform to on-premise system, we created a VPN connection. So for a VPN connection, you have a virtual private gateway and a customer gateway. A customer gateway should have public IPs. By default, for a VPN connection, you can create 2 tunnels. So observe that you only need 1 static public IP address at the customer, whereas the virtual private gateway at Anypoint Platform will have 2 static public IPs as seen in the screen, and also this has been shown in the configuration file that we got from the Anypoint Platform. So 2 IPSec tunnels are created in an active passive config. Now again, this can change depending on how you configure from customer gateway. So you might also want to have an active mode, so that is also possible. So based on how you configure at the customer gateway, the settings will take place accordingly. Another part which we saw was about the static routes or the dynamic route. So if you select border gateway protocol, so the routes will be dynamic, which means that the customer gateway will advertise its prefixes and how to transfer the data across network. But in case if you use static route, you have to on your own add the routes. So for example, here inside the on-premise system we have 2 different networks. One starts with 10.100.0.0/24, so this is one, and the other network is 10.150.0.0.24. So here I have entered manually the routes here. So based on the IP, it will select the route. Again, if there is any DNS server, you can add that as well. So all this configuration has to be done as part of routes. But if you select BGP, the customer gateway or the router will make sure that it advertises the active routes available. So that's all about VPN. I hope you found this series useful. Thanks for watching.